Hello chemistry fans, welcome back to Chemistry 1032 problem solving session at the Academic Success Center here at Broward College North Campus. I will be your guide, Dr. Russell Betts, leading you through this problem. Let's take a look. What do we got? Draw the electron dot symbol for each of the following: silicon, aluminum, calcium, cesium, sulfur, and nitrogen. Okay. So now the electron dot symbol is basically, well, not basically, it is the valence electrons arranged around the atom. Now, we all know that the electrons are stacked above the nucleus in energy levels, but right now for the electron dot symbol, we are only worried about the outermost energy level that has electrons in it. And that is called the valence shell, and inside the valence shell are the valence electrons. The valence electrons are what you draw the dots for. Those are what you draw the dots for, the valence electrons. So when a question asks for the electron dot symbol of an element or an atom, you are only concerned with the valence electrons, or the electrons that are in the outermost shell that are filling or have filled. All right, so let's take a look at silicon. Silicon is element number 14. So I'm going to give you two ways to do this problem. Silicon is element number 14. So we have to have 14 protons or 14 electrons. All right? So silicon has 14 electrons. So that's going to be 2, 8. So far we've filled up the first shell with 2 electrons, the second shell with 8 electrons, and now we're on the third shell, but we've used up already 10 of our electrons. So 14 minus 10 is 4. We still have 4 electrons left. So in the third shell, there's 4 electrons. So this, let me put an underline under it. This is the valence shell. The third shell is the valence shell. It's the outermost shell that is filling with electrons. So in the valence shell, we have 4 valence electrons. They're the electrons that are in the outermost shell. There are 4 of them. So we have to put 4 electrons in the dot symbol for silicon. Now how do we do that? Well, write Si, that's the symbol for silicon. Now, we have to put 4 electrons, or electrons will be represented by dots, around the silicon. So how I tell students to do it is just think of it as a map. On the top of the map, put an electron. So north, there's an electron. South, there's an electron. East, there's an electron. West, there's an electron. You have to do that. All the electrons want to be as far away from each other as possible, so put them at the 4 corners of the map if you want to follow that analogy. Okay? That's how you do silicon. Now, the other way you could do this problem, instead of doing the electron arrangement, is you could have said, okay, silicon right here. Silicon is in group 14 or 4A, depending on how you want to look at it. So now, how many valence electrons does silicon have? Silicon has 4 valence electrons. Take group 14, for example, and ignore the 1. Just ignore it. The 1's not there. For this problem, the 1 does not exist. Group 14 has 4 valence electrons. So carbon and silicon both have 4 valence electrons. Let's take, for example, nitrogen. Nitrogen's in group 15. So nitrogen has 5 valence electrons. Let's take, for example, oxygen. Oxygen's in group 16. So every atom of oxygen has 6 valence electrons. Fluorine. Fluorine's in group 17. So every element of fluorine has 7 valence electrons. See how that works? All right, let's do the next one. Aluminum. Aluminum is in group 13. So we just ignore the 1. Just ignore it. So aluminum has 3 valence electrons. So aluminum will be Al with 3 electrons drawn around it. Now I just went north, east, and west. You could have done this. You could have put this one. It doesn't matter. That's fine too. Or for example, there's other ones you could draw too. What I'm saying is it doesn't matter where you put them around the element as long as they're in 3 corners of the map. Okay? Pretty straightforward, I believe. Calcium. Calcium's in group 2. So it has 2 valence electrons. So calcium would be something like that. It's just the valence electrons. All right. Cesium. Cesium is right here. Cesium has 1 valence electron. And you just draw it there or there. It doesn't matter. I prefer it there. It just looks neater. Looks more pleasant to my eye. But you could have put it there and I would mark it right. You could have put it anywhere on the 4 corners of the map and I would mark it correct. But for me and probably for most people, having the dot right there is just more pleasing to the eye. All right, sulfur. Sulfur is right here. Sulfur is in group 16. So ignore the 1. 6. Sulfur has 6 valence electrons. So let's put sulfur down here. Sulfur. North, south, east, west. That's only 4 electrons though. Sulfur has 6 valence. So now we have to start doubling them. They start going in doubles like this. And I'll just put them here and here. So after 4 valence electrons, the electrons start to double up. They start to occupy the same side of the map, if you will. So now, here we have 1, 2, 3, 4, 5, 6 valence electrons, and 2 of them, 2 sides of the map, or 2 sides of the element, are doubled. There's 2 electrons. Let me just give you a couple of notes here. That is called a lone pair. Okay? Whenever the elements double up on one side of the element, say for example here or here, that's also a lone pair. Those are known as lone pairs. These are called single electrons. These are lone pairs, single electrons. Okay? Nitrogen. So let's put nitrogen up here. Nitrogen's in group 15. That means every atom of nitrogen will have 5, because it's in group 15, ignore the 1, 5 valence electrons. So let me see if I can find some room here. Nitrogen. North, south, east, west, and then double again. So now we had to double one of them. I could have put the lone pair anywhere around the nitrogen. I choose to put it on top. Mostly because it looks pleasing to my eye. If it looked better to you to put it on the right hand side, that would have been completely acceptable, or the left or even the bottom would have been acceptable. I would mark it correct. But for me and probably for most people, the lone pair being on top is aesthetically pleasing, so that's how we draw it. That's our lone pair, and those are single electrons. There we go. Getting a little scribbly there, sorry. So now, let's recap. When you put the electrons, the valence electrons for the dot symbol around the element, you start at the north, south, east, and west. That's how you want to fill the electrons around the element. That way, the electrons have lots of room. Remember, electrons repel each other, they hate each other, so they want to be as far away from each other as possible. When you start after 4 electrons in the valence shell, you have to start doubling them up and start forming things called lone pairs. And the electrons that are not doubled, those are known as single electrons. All right? So I hope that video has been helpful to you, and I hope that you have been able to figure out electron dot formulas. And if not, please contact one of the many tutors here at the LRC. Or, sorry, we used to be called the LRC, now we're called the Academic Success Center. If you still have trouble or you want to come and talk to one of your professors, please come by during office hours and talk to us. We'd be happy to help you. And with that, I wish you good luck and good chemistry.